Welcome to Part F on Unit 7 on Chapter 13. It's a very long chapter on inventory management, but very important. And what I'm going to be doing in this is just one more time going through an example of the calculations of both an economic order quantity problem and also an economic production quantity problem. So let's take a look at our first problem statement. So we have an item that we purchased from a supplier, and we pay $20 each for those. We have an average demand for this particular item of 5 per day. Now, every time we place an order, when we buy this, it costs us $5 per order. We have an inventory carrying cost that is 20% of the purchase price. And finally, the last piece of information is that the store works 200 days per year. So the first thing we should look at is to try to identify whether this is an economic order quantity or an economic production quantity problem. So the two methods I've given you for determining that is to look at the verbs in the problem statement. So we see that the third word of the first sentence is purchased. So purchase or buy indicates an economic order quantity problem. The other way that we can distinguish an economic order quantity problem is whenever we see an ordering cost. So the third sentence says it costs us $5 every time an order is placed. That's an ordering cost. So it's definitely an economic order quantity problem. So first thing we want to know is how much should we order at one time? So how much should we order every time we order? So let's identify our variables here, starting with the variable D, which is annual demand. So we have an average demand of 5 per day, and we work 200 days per year. So our annual demand will be 1,000 units per year. Our ordering cost, which is represented by the letter S, is $5. Now our holding cost. Now there are two ways in which holding cost can be represented in a problem statement. One way is just given a flat dollar amount. In the case study that you went through in previous parts, that's the way it was done. This way, we've done it as a percentage of price. So the holding cost for this item is 20% of the price. The price is $20. So 20% of $20 is $4. So either way, the holding costs are stated as a percentage of price or as a flat dollar amount. You're going to end up with the same thing, and that is a flat dollar amount. So $4, what does that mean? That means if we had one of these items and we kept it in inventory for 1 year, it would cost the company $4. That's what that means. So the economic order quantity formula is the square root of 2ds divided by h. So I'll plug in my variable values into the formula and do the calculation. So the economic order quantity is 50. That is the quantity that will give us the least total cost. Now the second thing we want to do is what is the average inventory? So pardon me a second here, I'll scroll up a little bit. We know that in the inventory cycle, we start off with some quantity, and we assume that we have a uniform demand rate in the economic order quantity, and that just as we hit 0, we get a new shipment in, and we go back up that quantity. So the average value is over that cycle, is the economic order quantity divided by 2. So the way we came up with that is that we take the inventory at the beginning of the cycle, which is our optimum quantity. We take the inventory at the end of the cycle, which is 0, and we add those two numbers and divide by 2. So Q plus 0 divided by 2 is Q over 2. So if our economic order quantity is 50, 1/2 of 50 is 25, so that at any point in time, our average inventory will be about 25 units. The next thing we want to know is how many orders do we place per year. So the formula for the number of orders that we place per year is our annual demand divided by our economic order quantity. And so the annual demand is 50. The economic order quantity, the annual demand is 1,000. Pardon me. The economic order quantity is 50, and so we would place 20 orders per year, or 20 times per year we would place an order. So how much time elapses between an order? So we order 20 times a year. How many days are between each of those orders? So the formula for this is our economic order quantity divided by the demand. You'll notice that that is just the inverse of the orders per year. Economic order quantity divided by demand, and then we're going to multiply that by either the number of work days per year, or if the problem is stated in work weeks, then we would be saying so many weeks per year. Don't ever try to convert, if the problem is stated in weeks, it works so many weeks per year. Don't ever try to convert weeks to days, because you're just going to get into trouble, okay? So if it was weeks, then you would say so many weeks elapsed between each order. In this example, we've stated it in work days, 200 work days a year. So 50 divided by 1,000 times 200 is equal to 10. So there's 10 work days between each order. And then finally, the last piece of information, the last calculation, is what is the total cost, the total annual cost for ordering and storing this particular material. So the formula for that is shown as Q over 2 times the holding cost plus the demand divided by Q times S. Now, I want you to take a careful look at the variable Q in this formula. You'll notice that the Q in this formula does not have the little O subscript, the O standing for optimum. So what that is telling us is that we can calculate the total cost of ordering and storage for any quantity. It doesn't have to necessarily be the optimum quantity, for any quantity that we buy. You know, even though the optimum quantity is 50, if I wanted to know what the total cost of buying 85 is, I could calculate that. I would just substitute 85 for the variable Q. And again, Q over 2, we know that that's the average inventory times the holding cost. So the first parameter gives us the storage cost, and the second parameter is the ordering cost. So plugging in the variables into the formula, shown on the second line, doing the calculation, we can see that the storage cost is $100, the ordering cost is $100. As we've said in the case study, that at the economic order quantity, and only at the economic order quantity, these two numbers should be equal to each other, or very close to equal to each other, within pennies of each other. And in this case, you can see they are exactly equal to each other. So the total cost for storage and ordering this item is $200 per year. So make sure that you know how to do these. You will be expected to do these same things, not only for homework, but also for exams, and also for the assessment quiz, which will be coming up. Now let's take a look at an example of a economic production quantity problem. So here's the problem. We're manufacturing shoes. So a shoe manufacturer wishes to have an optimum production of its best-selling shoe. So the demand for this best-selling shoe is approximately 1,000 per month. And whenever we produce this shoe, the plant can produce this shoe at a rate of about 200 pairs of shoes per day. Of course, we're always talking about pairs of shoes. We're not talking about individual left to right shoes. This is a pair of shoes, okay? So 200 pairs of shoes per day. And the equipment that we use for producing these shoes, there's some time it takes to get that equipment ready to do the work. That's called setup cost. So it costs $800 to set up the machine for each production run. Now, we keep these shoes in inventory, and the annual storage cost or inventory carrying cost means the same thing. Storage cost, inventory carrying cost, inventory holding cost, all that means the same thing. For a pair of shoes is $60. That is, if we kept one pair of shoes in inventory for 1 year, it would cost us $60. And we work $240 a year. So how do we know that this is an economic production quantity problem? So again, we look at the verbs, okay? So we see the verb produce in the word statement. That tells us it's an economic production quantity. Also, we see a setup cost. And when we see a setup cost, we know it is an economic production quantity problem. So we want to know what the economic production quantity should be. So our variables are, D is, once again, annual demand. So if we have a monthly demand of 1,000, 12 months in a year, that gives us an annual demand of 12,000. Our setup cost is defined to be $800. Little p represents the production rate at which we produce shoes. We can produce 200 pair per day. And the usage rate, that's our daily demand. So the usage rate needs to be in the same unit of measure as the production rate. The production rate is per day. Therefore, the usage rate needs to also be per day. So we have an annual demand of 12,000. And we work 240 days a year. So we have a usage rate or a daily demand, we could think of it that way, of 50 per day. And then finally, our holding cost is $60. So the formula for the economic production quantity is shown here. So now we have a subscript P instead of O for optimum for EOQ. So the square root of 2ds over h, and then we're going to multiply that times the square root of P divided by P minus U. So plugging in the variable values into the formula and doing the calculations, our economic production quantity should be 653. That should be the quantity that we should produce in each run. Now, We'd also like to know some other information. We'd like to know what is the maximum inventory level that we achieve in a production run. So the maximum inventory level, the formula for it is the economic production quantity divided by P, and then multiplying that by the difference between the production and the usage rate. So substituting the values for this, doing the calculations, our maximum inventory of this particular pair of shoes will be 489.75, or we'll just round that up to 490 pairs of shoes. That's the maximum inventory that we achieve, and then we start using up that inventory until we get down to zero, and then we start all over again and we start producing shoes again. So what is the cycle time? In other words, how many days will there be between a production run of these pairs of shoes? So the cycle time, the formula is our economic production quantity divided by the usage rate. So our economic production quantity is 653. The usage rate is 50 per day. So about every 13 days, we're going to have to start making these shoes again. And then finally, what is the total cost? What is the total setup cost plus our storage or carrying cost? Now, the formula for this is very similar to the formula for the economic order quantity. The only difference is we are inserting the maximum inventory as our value in here. So the first parameter is the storage or the carrying cost. Second parameter is our total setup cost. So substituting the values in here. Now you'll notice that the calculations here for the carrying cost, we get $14,700. And for the setup cost, we get $1,959. And those two numbers are not equal to each other. And they're not equal to each other because that phenomenon of these two numbers being equal to each other is only valid for the economic order quantity. This is an economic production quantity. It's only valid for the economic order quantity at the economic order quantity number. So we don't expect these two numbers to be equal to each other since this is economic production quantity. So therefore, the total cost of carrying this inventory of shoes plus all the setups we have to do will be about $16,659. And this will conclude part F of this unit.